Hi guys, so today we are going to be looking at how to calculate the moles of an element in a chemical formula. So for example, let us say we are given aspirin, and aspirin, A-S-P-I-R-I-N, aspirin is C9H8O4, C9, C9, C9H8O4. Okay, so C9H8O4, this aspirin contains, normally we call it 9 carbon atoms, 8 hydrogen atoms, normally. And we also call it, in a molecule, 4 oxygen atoms. Okay, but if you're talking about just one molecule, then that's the story. So one molecule, yes, this one molecule is made up of 9 atoms of carbon, 8 atoms of hydrogen, and 4 atoms of oxygen. But if you change it and you say, what about 1 mole? 1 mole of aspirin, which is still C9H8O4. Okay, then how many moles of carbon, how many moles of hydrogen, and how many moles of oxygen does it contain? The story still remains the same. It contains 9 moles of carbon, 8 moles of hydrogen, and 4 moles of oxygen. Clear? Now, how do you write this? So we are going to write this as 1 or 9 moles of carbon are present in 1 mole of C9H8O4, or 1 mole of C9H8O4 contains 9 moles of carbon. Okay, 8 moles of hydrogen are present in 1 mole of C9H8O4, or C9, 1 mole of 1 mole of 1 mole of C9H8O4 contains 8 moles of hydrogen atoms. Okay, another one is the 4 moles of oxygen are present in 1 mole of C9H8O4, or 1 mole of C9H8O4, 1 mole of C9H8O4 contains 4 moles of oxygen atoms. Okay, so these are the different conversion factors coming from the same molecule, or 1 mole of aspirin, which is C9H8O4. So it depends. What are we, what are terminologies, is what is the language? So if you're talking about one molecule, we are going to call them as atoms. And if we are looking at the moles, that is important. If we look at it as moles, then these become moles. So just pay attention to that, okay? Next thing is, these are the conversion factors. So these are conversion factors. Now, the thing sometimes students get confused is that how come there are 9 moles and 8 moles, and so you just have to look at it as parts to whole. Parts to whole. Let us say you have what do you call? Let's say a bag right? And this bag contains candies. So there are some like M&Ms, you can say, a packet of M&Ms. So these are these chocolate candies. So these are some candies right here, blue colored candies. And then there are some red colored candies, chocolate candies, just layered, you know, and then there are some other candies also, peanut butter. So you see, so there are, I'm going to just erase one of the blues. 1, 2, 3, and 3, 1, 2. So 1, 2, 3, 4, 5 blues, and then one, oh, sorry about that. Okay, anyway, so, okay, this is our bag, a goodie bag in which we have some candies. So 1, 2, 3, 4 blues, and we have some 1, 2, 3 reds, and then we have 1, 2, 3, 4, 5 yellows or 6 yellows. Okay, so these are the parts. So we have 1, 2, 3 reds, right? And we have 1, 2, 3, 4 blues, blue color, and then we have 1, 2, 3, 4, 5, 6 of the yellow colors. So yeah, all these are big, but these are all the small parts of one bag of candies. Okay, so this bag of candies, this bag is that whole. This bag is a whole. Okay, the bag of candies is a whole, and these are just the small parts of that one big whole. Okay, so parts to whole, that's one thing. Now let's look at these problems, the learning check problems. One of the examples I'm going to take it, and this is from a different book, and that is you are given propyl acetate. Okay, let us say this example, propyl, P-R-O-P-Y-L, acetate, A-C-E-T-A-T-E, and the formula of this is C5H10O2, okay, gives the odor and the taste of pears, okay. How many moles of carbon? How? The question is how many moles of carbon? How many moles of carbon are present in 1.50 moles of propyl acetate? Okay, propyl acetate. Okay, now the question is asking us moles of carbon that are present in 1.5 moles of this one big propyl acetate. So these are given to you, these three things. So you're going to write down in 1 mole of propyl acetate, which is C5H10O2. There are 5 moles of carbon, right? So this whole thing can be written as 5 moles of carbon are present in 1 mole of C5H10O2, or 1 mole of this whole C5H10O2, there are 5 moles of carbon. All right, so which one are you going to use? You are given 1.5 moles of propyl acetate. So you are given 1.5 moles of propyl acetate, which is C5H10O2. Okay, the question is asking us how many moles of carbon. So the moles of carbon, this conversion factor you're going to use. Why? Because this conversion factor allows you to cancel out the moles of C5H10O2. Okay, so 5 moles of carbon are present in 1 mole of C5H10 O2. And moles of C5H10, moles of C5H10 cancel out, and you are left with the moles of carbon. So now you just do the math, 1.5 times 5 divided by 1. And that's going to give you 7.50 moles of carbon. Okay, that's the answer. Similarly, let's just do the same thing. If you are given, so this is, let's say, this is one part. Let's do another question, which is similar to this, but here you are given. So here, how many moles of C5H10O2. So this is the propyl acetate. Okay, so how many moles of C5H10O2 contain 0.480 moles of oxygen? Okay, basically oxygen atoms, but how many? So so in a way, you are given the moles of oxygen, right? And you being asked how many moles of this. So you need to find the moles of C5H10O2. So how will you write this? Here, in this case, you are going to write down what is given to you, 0.480 moles of oxygen, O, just a O, okay? Moles of oxygen atoms times, we need to get rid of the moles of oxygen atoms. So that's going to be here at the bottom, moles of oxygen atoms. So let's just put it atoms, are present in 1 mole of C5H10O2. 1 mole of C5H10O2 contains 2 moles of oxygen atoms. So 0.480 moles of oxygen atoms is going to make how many moles of C5H10O2? Okay, so moles of oxygen, oxygen atoms cancel out. And you are left with 0.480 times 1 divided by 2. And your answer comes out to be 0.240 moles of propyl acetate, which is C5H10O2. Okay, so these are the parts to whole problems, which you know, will be useful in determining the empirical and the molecular formulas. So at this point, I'm going to stop recording, and thank you for watching.